Hello there, it's about time. Let's see. I will develop in this pane as well. Okay, so yeah. I think we need some elf stuff, right? Alright, LSP is gonna load up. Well, it does this. We could just fix some things in Chatry, cause yeah, why not? Okay. Here's a pane. Arch traits, CPU memory. Yeah, I'm not sure about memory. I assume we do paging 100%, like, yeah. So yeah. Do we actually set loan files or portable executables or something else? I don't know. I'm kinda leaning towards L files, because they are standard. And they are pretty simple. Okay, so first of all, let me just look at this. So for Chatry, I wanted to tweak a few things real quick. So I need the leaderboard. This, no, this, no. Here. So pretty simple. This is a vertical container. Let's change it to, wait, HBox. Oh, let's change it to VBox. Wow, this is laggy because full screen, I don't know why. Then let's add an HBox as a child. And let's put everything. Sorry. Let's put everything in here. And then let's add a label. Label. Do we need rich text? Well, I can always change it at the top. So this is gonna be title. Flashy Dex leaderboard. I feel like I want rich text there. I feel like I do. So center, horizontal alignment, center, or fill. I know, center. Vertical alignment, fill, top. I guess I can keep top. BB code's enabled, of course, because otherwise it doesn't make sense. They use it. I wanna also do fill or something. Fit content, that's what I want. Here it is. No. Do you have any padding here? Because I feel like there is too much. Hi, Vatican. Theme overrides, maybe constant separation. That's not what I need. I want padding or margin or something. Cause this space, I wanna get rid of that. And also maybe I do this. Why is the eye looking like, I don't know, just not it. Markup, custom effects. Let's make it also outlined. Chat theme, of course. Let's make it bigger, which I don't actually know how to do. Well, I mean, I could do BB codes again. Font size 20, 30, 25. Looks good. Here's the font size. Do we color it? I want to take a look at how Twitch does things. Let me see. Because I actually copied this basically from Twitch. From Twitch's clip leaderboard. Well, it was supposed to be. I gotta wait for Twitch to load. Oh, there is no leaderboard here. Let's switch to a different streamer, me for example. And they can also pop this out. So, oh my god, it's gonna go to mod view, right? It's fine. So will this this does not display leaderboard. That's annoying. Okay, let's go to this guy and let's see if we can see the leaderboard here. Well, it should at least be there, hopefully. Please give me the leaderboard. There's no leaderboard. Also, it should load at some point. Nothing. I'm just gonna Google it at the end of the day. Oh, here. Here's the picture of what I was going for. Oh, that doesn't explain anything. Right. Okay. Well, that's not even close to what we have. I guess let's do color. Gold. That's extra. Color. I don't know. Or should I just do it for this? I'm not a designer, you know. This looks silly. Green. Yeah, that's toxic dark green. It's gonna look bad. Red. Oh, this actually might be. So what's? Am I the only one seeing this? Oh yeah, that's just piece of dust on my monitor. Yeah, I don't know about colors. Maybe should just keep it uncolored and keep the leaderboard like colored, something like that. And then I also wanted to test cheers, but it's gonna be pretty hard. Let's restart the overlay. Oh my god, what is this? Okay, I think we need more spaces. 2 spaces. Hit API. Let's restart it again. Hopefully I saved. Yeah, that's better. Also exclamation point. Wait, where is it? Oh my god, it's here. Okay, let's restart it again. Sure, nobody notices, right? Those 2 spaces are gonna be bugging me. Okay, maybe I get rid of bolts. Wait, it's messed up. Or make the whole thing bold. Okay, let's try that. No space in between. Like, why? I think I'm gonna go with this. Maybe it's too bold, you know. Maybe it is. Let's try that. I mean, I guess this is good enough. Although I still feel like there is not enough space between the 2 words. Might just be me, might just be outlines. More floating text, right? No. Wanted to test cheers. I'm gonna cheer 1 beat just to test it. Oh wait, I can't. Oh. Well, I guess. I guess I can't test it. Unless I spin up a server, which I don't want to do. Also, I don't like the absence of space here. I think I'm just gonna go with this. I'm not sure because, like, it was probably supposed to say something about the people. So not the leaderboard, but like winners or people who have most plushes got. But that's too long. Chat message label. Oh, it updated the path, right? Good enough for now, I guess. Wait, I actually had the leaderboard in chat all this time. I could have just looked at it. Oh my god. Okay, sure, I guess. Let me do this and then tab this. So that's done. Now let's get back to Satan. Anything I want. I want memory to work now. So let's do this. So what do we have? Yeah, area reservation. So normally you would load ELF files from disk. And for that you're gonna allocate memory inside of virtual address space. At specific ranges. Yeah, what if I, instead of like loading those as ELF files, I'm just gonna load them as regular files and then parse ELFs whenever. Welcome back. You can see the text edition. Say it if you like it or not. Or if I should change something. It does have 2 spaces in between Plushidex and leaderboard because 1 space was not enough. And that really bugs me. No. So, yeah, memory allocation. Yeah. What do you think it was? What would you think it was? It's okay, memory map, and we go through memory map, and we add stuff to page allocator. Yeah, right, that's not quite how it works. But I mean, good enough. And it also fails to add memory zones because of allocator. Which is here. What is this? 1000 in hex. I actually don't know. Well, that is 4 kilobytes. I'm just trying to balance it out since last time you were the one who voted for the thing I did. This time I'm doing the opposite, basically. So Penguin Operator now gets to choose, basically. Yeah. I'm just trying to balance it out. It's just the most natural thing I feel like doing. Balance out the universe. Yeah. You might get another chance at building Arch, because I have... I'm just gonna spoil something. A while ago I made root.py, which it doesn't really matter, but it has some Arch downloading logic. So it can already fetch all the packages. No, it's gonna be too difficult. And also, I want the stream title to reflect what I'm gonna do during the stream. And when it's a VOD on YouTube, I want it to reflect what I am doing during the stream. I can't have 2 titles, one for the first half, second for the second half. That's just not how it works. Okay, so let's see talk. I don't know, out of memory. Out of memory handler. Okay, sure. We recently needed a feature from a library, so we forked it, and it was wipe coded. Sure, I guess. Okay, let's see. FMT. Clear Wales, register gap, malloc. Layout result. So if you find sufficient chunk, unless if you can't, then handle out of memory. Given the allocator and the layout of the allocation that caused out of memory, size or claim and return. Or fail. If the allocator is still out of memory, therefore an infinite loop will occur if OK is repeatedly returned without extending or claiming new memory. Or you out of memory on the whole system. Error doesn't do this. Then we have claim. Claim has span. If span is empty, then we just claim the span and set it to empty. That's simple. Okay, so this I should be able to replicate the behavior, but with allocating new pages. Initial arena. So we're gonna have initial arena. A map. Which that works, right? Wait, that's not how we do this. So memory kernel address space, right? Setup paging will. So let's do initial option of span. Address space. Wait, address space is gonna be. That's annoying. Oh, wait, no. It's not sufficient. What is this? S expression blob reader RS. Keep leading white space efficiently. Trim start if it's empty break. Okay, sure. This is a string slice. I mean, it is efficient enough. And then what's next? Or is this expression? Satan? Yeah. Hi, Cuckoo. Demonic operating system. Okay, so it's not address space. I need the border. Okay. Rust compiler has many doc comments. Well, actually, okay, tabs kind of weird. But like, Rust C has as many doc comments. So no, it doesn't say that it's wipe coded anymore. Because in Rust, people write more doc comments than you can imagine. Some people, like, yeah, if you saw that much docs in C++ code base, that would be weird, especially in private stuff. But in Rust, like, I try to write docs for private functions in Oracle, because that's how Rust does it, and that's and that's useful, because when you want to dig into the compiler, wipe coding in Rust is bad. Well, I don't know. I'm pretty sure. I'm pretty sure it's gonna work. I'm pretty sure AI is good enough. Hold on. Cursor shows Rust on its front page. Well, that means it should work fine. It should be easy. Omar key. Oh wait, what was it? It's an OS that's like Arch with. Is that it? It's like Arch but opinionated. Yeah, exactly. Oh well, it says all my thoughts here, literally. It's opinionated. It's opinionated Linux. Looks pretty beautiful, looks pretty modern, sure. But it's opinionated. It's like, it's a distro that this person would use. You're thinking of switching for it. Sure, if you like it. It probably will not fit you perfectly because, well, it's opinionated. But you can always uninstall stuff and install more stuff. Cool. Back. Better than NixOS. Okay. I will not agree on that. That's not true. Nothing is better than NixOS. Except for an OS with build on stream. Anyway. So yeah. I'm gonna change to like a neutral page here. AI mode. 10 out of 10 rage bait, of course. Okay, so mmap on out of memory. Let's qualify as talk span. I mean, I knew it was rage bait. I still had to rage on it to prove my point. Anyway, so how do we claim more memory? Oh wait, we need page allocator, right? Wait, we don't actually really need it because it's global. Yeah. Well, every time I just post a poll on Discord. What should I do for this stream? And this time I'm doing kernel stuff. Because last time Orko won, I'm pretty sure. And Penguin Operator got a stream at some point about kernel dev. Okay, so I don't really care about the layout. If ohm handler, I'm just gonna qualify everything. So if ohm handler is initial, well, I guess I could do span here, right? Actually, do I care about initial arena? Because I don't care about memory mapping. Memory mapping was done in the bootstrap. Size. So I just need to handle out memory. I'm gonna do talk claim a span. Oops. So page allocator. Page allocator must exist, right? Oh wait. In order for page allocator to work, we need to claim some initial memory, right? Allocator. clean. Up to super. Here. Claim. Wait. It's a helpful library. Sure. Okay, so claim. When it parsed an expression, it didn't return how many bytes it read. That was your PR. Okay, sure. I don't really know how useful this is, though. I see all the time when something, all the time read functions return a number of bytes read. I don't actually know where it's useful. I mean, if you do reading from slices, well, you should already have it tracked, right? To advance. How can you parse multiple expressions? Well, chain parses. Or does it have a function that reads from a slice or something, and it just doesn't return, and it just doesn't return how many bytes it read, so it reads and it gives you the start again. Well, that makes sense then. Still, like, why would you not use a cursor? I mean, is there? Just don't give a slide back. Not that. Wait, here, this one. Why not use this instead? It tracks stuff. It's basically a write and seek implementation for a slice. So you create a cursor on a vector or a slice or something, and then you just, well, for the case of a vector, you write to it. For the case of reading, you can just read it. So I would probably use that. Anyway, page allocator. Memory. Yeah. Create arch. Hold. It's a struct implement arch trait. We should have traits. Helpful part is that you can inject custom symbol parsing logic so you can get it to parse your own type of symbols instead of raw strings. Just a from str like bound. Well, read normally still is more useful. I'm starting to think maybe I should make a language that's just function calls, but not as expressions. We're talking about something else. Also, you're talking about why the library is useful. Are you not? Why can I not? Here. Oh, right. Yeah, no function definitions. Do we need them? I mean, I guess sure, function definitions, type definitions, and yeah, I mean syntax for like executing is just function calls. Let me see how that looks. Okay, I'm not looking for the right thing. Excuse me? I did not ask AI. I asked Google. atom and expression. Well, that's what I thought. Well, maybe. Elixir. Well, just look at elixir. Erlang VM. Oh my god, this again. Functional stuff. Oh wow, this actually looks pretty good. Recursive. Oh wait, received. Okay, wait, hold on. This looks like a regular language. Hold on. Anyway, so yes, this looks like a regular language. This looks like Haskell. This looks like a regular language. This looks like an interesting struct literal. ML like curried lengths also have a similar unified lambda calculus inspired syntax. Oh, why? Whatever. So yes, it does not look like a simple syntax because you have operators and this at the same time. Haskell, camel, etc. Here. Anyway, so memory, right? Do I not have traits imported in here? Let's create arch traits. Okay, you know what? Maybe if I move traits out. Oh wait, Arch has types, right? That's why I don't really need it. Memory. And then. Oh wait, no, I do still need traits, or do I? Memory trait. Page allocator. Why is this not accessible? Okay, so I should still import all the traits. So what if I do this and then I do use super split rate as underscore. So we've got logger CPU memory arch. Logger CPU memory arch trait. Public. re-exported as anonymous. This should work, right? If I just include this import. Wait, I don't need it there though. No way. Create memory page allocator. Huh? Wait, does it not recognize? Hey, what do you mean? This doesn't work? Why does it not work? It doesn't work either, like that. Oh wait. Oh right. This should work. Right now. Page allocator alloc. Use size. Oh right. What's the page size? If lift sx purse to have a name outside parentheses, you'd get define fibo. Define parentheses. Oh my god, what is that? Define opening parenthesis, name, quotation mark, n in parentheses. Is it in the Helix? Okay, sure. Does Helix have SX programmer? Wait, actually, that's not SX programmer. Okay, sure. So I assume those are the arguments to define function. This is if. Oh my god, we don't even have parenthesis matching. So annoying. Long scheme. Well, that's pretty helpful. So if I just do that. Wait. And then if I unwrap this as well. Okay, this makes sense. What is a negative sign? Oh wait, that's... Oh, that's a subtract function. Right. Oh yeah, that's pretty nice, actually. That's pretty useful. I like this syntax a lot more. I assume this is... Oh, so quote is quoting. Alright. Oh wait, or is it a list? Well, I assume you need the... I assume those are arguments, so a list of identifiers. But you can't have a... Well, I mean, if it's macros, then I guess, sure. Yes, experts are interesting, to say the least. Blocks, okay. So let's read, allocate blocks. Huh? Oh, it is its own body. Page allocator. Page allocator trait has alloc size page size. Let's just do 4K. Also, we do use large pages. So it's a page allocator, which is a page allocator trait, which I guess I need to import. Or should I add another? Wait, I should probably add another trait here. UCT. What? Oh. You hate wardrobe, don't you? You do. I know you do. I know you hate it. Well, I know you don't like it at least. Okay, so into to convert page size into size. I mean, sure, but no. I have that rate. What do you mean? Wait, page allocate was supposed to implement that rate, right? Yes. What does it? Oh, it's zoned body is my wrapper. Unlock option, physical address. I'm gonna rename this to alloc bytes and free bytes. Or alloc free zone in the alloc zone. Or a region. To make names easier to distinguish. And this is not a lock region, this is a lock. As page allocator trait. Now that works. Okay, Rust compiler or analyzer. Weird. Some page equals. Or I guess I could match it. So none is gonna return an error. Could not allocate it. Sum is gonna return an OK. However, I need to add the page, which is a physical address. I need to convert it to span. So physical to virtual. Is to word. Physical address page. SPTR. Yeah, SPTR for now. Okay, so we need to claim. Okay. Expected unit found result. What do you mean? Why are you expecting unit type? Unsafe, yeah, unsafe. Plenty of unsafes here. Okay, so span. New. 2 pointers from base size. base size. Okay, so let's do let size equals page size 4K. Then we'll do size here. Is into use size, and then for base we'll do it as PTR or as mute PTR. Oh my god, the sun. Because of the sun I'm not gonna be able to see myself, my monitor. Make type aliases inside the function. You can do everything inside of a function in Rust. You can do imports, you can do type aliases, you can do structs, you can do more functions. And that's incredibly useful. I mean, I do mostly imports. You can't infiltrate. Can you not impl? Well, maybe you can't impl, but that's impl. std fmtd display 4s. Wait, core. Can you not? Wait, this does not show any signs of errors. Inside of a function, inside of an infiltrate, inside of a mod. Looks correct, looks like you can. Yeah, Rust is great. It's not what I wanted to do. So yeah, this should work, although we need to allocate initial memory. I should probably just use talk asterisk. Or I guess talk span and talk. So we're gonna do I'm gonna restore some lines here. This. I wanna restore this. Okay. Reload. Infinite size. Just not infer it. Okay, it's fine. Initial. So we've got initial. We've got this. Git out new. So this is gonna be a map on all out of memory. Grow, that's not what I need. Bulk free, shrink, claim, mute self. I assume I can't claim until the start. So I'm just gonna do allocator claim. I'm gonna init. Okay, I'm gonna init the allocator. Public to super. lock claim. Unsafe. Initial. Arena. Let's work. Okay, so what? This, right. Just runtime may allocate before main is called. So we need to initialize it automatically. Okay, maybe I should. Well, okay, no, Rust is not gonna call anything before main is called. Because I call main. Spin mutex and map on out of memory. Get rid of some of those. Also, I can do this probably. Oh, yes, better. Oops. Okay, now. Okay, no, sure. Can keep that. I can get rid of that. And I can get rid of span here. Talk K. Okay, sure. I never understood those names. Map on out of memory. M map on out of memory. Okay, that should work. I realize I have not actually tested the kernel today at all. Not even compiled. I haven't even compiled. And right. This is still there. Can get rid of that for now. Because we need to figure out memory and sort it first. Right, address space rs. Here. To do. Sure, that should work. Right. Unmap, free map, alloc, tests. Alright, tests are not ready. Let's just run it instead. TMP page. TMP page was removed like forever ago. Because it's useless now. CMP page. I'm just gonna comment all of this out and to do it. Because memory mapping, memory management, and everything is gonna be completely rewritten. IDT setup well, looks fine. And empty boot module stuff, which, well, it should have probably done something, right? Should have probably printed something. Setup paging, IDT setup. Wait, IDT setup, it never says paging is done. Wait, I never say paging is done myself. Setup. Which it isn't really. It's pretty broken. YouTube check. Okay, that's not a good sign. We might have gotten stuck. Yeah, we probably got stuck during allocation. Yeah. Let's debug. Fortunately, our print implementation should be allocless. Allocating more pages. Oh, it's my clone. No, that should run. Well, it called it once and froze. What? Oh, it might have been that. This thing might need to do stuff. Okay, if I comment this out and just error instead, it's gonna fail and go work. Yep. Which means yeah, page allocator allocates. When I do this, it allocates regions. It uses a lock. Zone body uses a lock. Oh my god. That's a problem. So have talk. Binary body. Wait. I want to search crates. AC dialog, bare metal locators. 3 years ago, one version. And must say. Slab allocator. Greater available no STD and no global out of memory handling environment. Yeah, that's a problem. Well, body is what I want, right? We have block size, we have number of levels, and we have a backing allocator, which... Oh, you only need deallocate. What? Subvert rate of allocator. Well, it's sealed. Huh. RAM and Mayor RAM. It's for a region of memory without immediately allowing to access any of that memory using the body neuron populated to the allocator over time. 16 key region of physical memory. Oh, that sounds good. Then you do neuro. Bad things occur. Neuro unpopulated. Then we can't allocate, and then we add regions. Made by the global allocator. Yeah, I mean that's not helpful. Because we need binary body. In order to allocate more, we need to allocate more. In order to allocate more RAM for the allocator, we need to allocate more. That's a problem. Lock region. Not going anywhere right now, but yeah. This bookmark has been the most useful bookmark. The bookmark that I use the most, honestly. Yeah, it's important. It's just for a reoccurring event, basically. That's for going home, by the way. Yeah. Hello there. Fetch and yeah. Oh, that's tracking. That's funny. So what can we do? Current CPU and try a lock. I was gonna have to allocate some stuff. I mean, I could increase the size. I don't know if it's gonna be very useful. No, it's not. So what should we do? I need a binary body that's like that can allocate without allocating. Ideally. Quantum data? No. So the script has not been updated much. PR body. I guess not quite what I need. Wipe ThinkPads laptops with ease. No, not quite. That's just a kernel we've been working on. Together with Texelware, or I mean, I am a part of Texelware technically, so yeah. Improvement decision diagram. AI. Typing accuracy. Locator. Why is Oxid there? I mean, I don't know what it is, but I'm pretty sure it's not what we need. Static cell. Embassy. Sounds familiar. Statically allocated initialized runtime. Well, that's in standard, right? Like you have this in standard library now for a while now, like half a year or something. So yeah. That's not the problem. I can just make an arena. That's not the problem. Some implementation that Oh, right. Does one cell requires TT? No, it doesn't. One cell is available without STD, so... Or one slog. One slog does. So I'm pretty sure you can do it with one cell as well. Or just do it with an unsafe option. Unsafe static mute option. So yeah. Problem I'm facing right now is, so we have kernel setup. Leave dangerous. Oh, of course. Allow that. So yeah, we initialize allocators, other things, and then we set up paging. So this thing takes the binary body allocator and adds zones to it. At some point, binary body allocator gets so many zones that it needs to allocate more memory to keep track of those zones. And it allocates so much memory that global allocator cannot keep up and needs to grow. But it can't grow because in order to grow, it needs to take this page allocator and ask it to allocate more pages for use for global kernel locations. And this page allocator, in order to allocate more pages, asks the global allocator again to resize its internal vectors. And yeah, at that point, global allocator is already locked, so we can't really do anything. So that's the issue, which I am awful at explaining as always. Start and page allocator. Yeah, no, it might be that we are adding zones instead. It might be that we're locking when we are trying to allocate it and adding zones at the same time. So it might be locking on the page allocator stage. I'm not sure about that. So alloc region tries to allocate for any those. So this thing, I assume. Need to check. This thing I assume does allocate. Penguin operator, hello there. Someone zig. As you can see, we're doing kernel stuff. And we're stuck at memory stuff again. I hope they will never return to it, and yet I am spending all my time there. Page allocator alloc. Yeah, I'm not sure what to do with this. So in theory, binary body cannot really do much without oh wait. What was the tree command? File explorer. File picker. Yeah, this so wait, no. Now we have page allocator. It needs global allocator to allocate stuff, which means well, which means we need to allocate more RAM before Um, before we get to low, which I don't know if it's possible or not. Or we could literally use a global allocator for that. Because global allocator is like, yeah. It should be capable of allocating pages. Or should it? I'm not sure. Okay, so we surely need an allocator. Then this part, I just don't like it. I don't know where to search for an answer. Years ago. 0.0.2 does not have a readme. Yeah, that's not quite. Polished project, I wonder what it is. Operating system foundation and toolkit. Why is it like hoverable but not clickable? No follow, no opener, no refer. Okay, whatever. Codeberg. Polished OS. Wow, this is kind of updating. Last commit August 12th. Experimental operating system foundation to be accessible, modern and more just person project. Libsyn POSIX standards. Limit boot protocol or Dmine. Useless. Actually, this might be interesting. I know what Limine is. A bootloader, yeah. But I don't think I heard of a protocol. Linux, multiboot 1, 2, chain loading, and this one. Modern portable featureful. Embarrassingly long time to read this word. Extensible documentation, Limenis H file. Okay. The executable is the kernel, or otherwise the freestanding application being loaded. All pointers are 64-bit wide. All non-null pointers point to the object with a higher half direct. What? All non-null pointers point to the object with the higher half direct map offset already added to them. Oh, okay, so they are all. Thank you for the follows. Vaik and Slink Avenger. That was synchronized. Says list. All responses, the structures placed in bootloader reclaimable memory regions. That already sounds better than multiboot 2 at least. Back to back high. Yay. Base protocol revisions, features. Centered around concept of request response, collectively named features. Okay. In certain terms, a feature is comprised of two structures, request and response. A request has three mandatory members at the beginning. ID revision and a response pointer. ID of the request. That is interesting. One of the same request, bootloader will refuse to boot an executable multiple same request IDs. Revision of the request starts with 0. Loader load time with a pointer response structure. If the request was successfully processed. Yeah, okay. Entry memory layout. Protocol mandates executables to load themselves at or above this address. Lower half executables are not supported. For relocatable executables asking to be loaded at address 0, a minimum slide of this is applied. At handoff, the executable will be loaded and mapped as supervisor. Memory placement is guaranteed to be physically contiguous. Executable address feature. I read it as HDMI for whatever reason. Caching, I mean, that's pretty cool. Machine stated entry. But yeah, probably not gonna be using it. Wait, come back to polished. Kernel, this memory management, initialization, offloader. Not used for booting. Make. Okay, anyway, so that's not very helpful. Well, right now at least. So how do we add stuff? I realize that this is not gonna work. So, because when we go out of memory, in order to map more, we need to use an allocator, which we don't have. Kernel allocation. Do we really need a lock? Like, well, we need it for memory allocators and for that's it. Yeah, pretty much we only need it for memory allocation, for page allocators, and page allocator is important. It's a binary body. Could we do a lockless binary body? Rust. So this thing. Well, malloc free classic C standard library for functions for dynamic memory allocation. The malloc chosen platform. Calls them by sleep secret FFI OS allocators. Operating systems provide low-level primitives for memory management, such as virtual alloc windows, mmap, Unix, or sbrk, which is sysbreak, system break. System calls, yeah sure, global allocator, Rust, PyMalloc, Python specialized allocator What? Why do we have this here? Arena. Slab. Garbage collected. And custom. Whatever. Boot time allocator. Early bump stack allocator. Nearly from a fixed size heap. Usually the allocations are not supported. Yeah. Stack allocator. Physical page frame allocator. So there. Why is there a lot of intro between Python and low-level languages inside of this? Inside of a collection of allocators for the polished project. Okay, sure. Let alone allocators. Inside of the polished project. I mean, I'm not gonna criticize this project. It looks pretty cool. Why I'm on a repo with a cargo workspace? Yeah, I agree with this. Agree with the monorepo. So I assume this does not do Python, really, because they don't even have POSIX compliance yet. Machine learning, sure, but here, so again, this is what was it? Where was I? So this is polished project, an operating system. It's not supposed to have Python yet. I know. I mean, polished means an operating system. It's polished OS, polished project. As an experimental operating system, which does not have POSIX compliance yet. Where is it? Eventually POSIX libc compatibility, but it's not yet. So I assume it does not support Python. Then why are you mentioning Python in the talks? That's such a weird arguing point. Well, eventually. Yeah, I don't know. I assume that's just something to do with allocator. Like, it's not that you're gonna have Python support built into the kernel and then have it use a specific allocator for its allocation. Like, why? I mean, sure, that could happen. That would be weird, I think. Code profiling. Very reimagined. If you look at its implementation. Oh, so if it's very reimagined, then I assume that reimagination was just copied here. Implemented in the CPython runtime for small object allocator. Python code does not call it directly. Yeah, sure. Oh, so this is. I still don't get why you have it in the kernel as a standalone allocator, or they literally say that Python code does not call this directly, but it's used for object allocation, which makes me think that they do want to have Python built into kernel. Which, I mean, I'm not really against it because I like Python as a language. But like, why? It's like, it's beyond monolithic kernel. You start to build apps into the kernel and language runtimes. Imagine if Bash was part of Linux kernel. Anyway, so what if go into main and get rid of alloc? Allocator API, doesn't matter. Slice from pointer range, not for now. Now this is gonna be angry, right? Yeah. Yeah, but Bash interpreter is not part of the kernel, and it should not be. But it pretty much is an interactive layer on top of libc syscalls, although nowadays I'd say it's more like an interactive layer on top of executing executables API or something. Because how many syscalls does Bash use? Does Bash expose like natively? You use cat to output a file. That's a program. That's not a syscall. You use ls. That's a program. That's not a syscall. Nowadays, before it was. You use echo. Sure, echo might be a syscall. Printf. I mean, it's a function. Technically, you can count it as a syscall because it's just outputting stuff to the standard out. Read is a syscall, I guess. Bash has a lot of stuff like that, but people don't use it nowadays. Now you just use core utils for fancy things. Sure, you can read the file with Bash without having to use cat, but would you rather use cat or would you rather write it by yourself or use cat, which is just simple, just print stuff out. Well, it dumps the contents of a file into standard out, which is more correct to say it. Yeah, now how do we allocate pages? Spent a lot of time here, I have every second of it, and yet I am doing it again. Of course. Oops. So what should we do with the page allocator? I feel like it should be self-sufficient. I see it. Lock-free body. Oh, that's the one I used, I'm pretty sure. Cloudflare blog or something. Oh, what? So yeah, this is 8 months ago at Loom test. Does it have my issue? Closed. Yay, my issue! You wait when you have time. Yay! My issue was there. Anyway, so input, storage time, single page log, huh? Well, anyway. So let's use the global allocator. Can it use itself as an allocator? So I want to see this. Our kernel is currently static. Tacos. What am I reading? Is this a documentation on how to make a kernel? Haven't gone that far. First define an interface for physical page allocation. Why is there a mosquito? Oh yeah, sure. Number. Why is there a function called number? Page beats, okay, sure. Page beats, page size, page mask. Offset, round up, round down. Yeah, this is used as bitwise note in Rust, which still feels weird. Okay, in memory lists. List. Oh, why is there an in-memory list? Mention free. Okay, so allocator, max order plus one lists. Okay, so and the one you insert ranges. List push. Item pointer mute. So a list head mute size. Let's move to the next node. What? Oh wait. Oh my god, that's so smart. So this is a linked list. And each item of a linked list is a page which is not allocated. Or a region which is not allocated. Whole point is, since it's not allocated, we can use it to store metadata about it. And when it gets allocated, we don't care about this metadata. Oh my god, that's so... By the way, yeah, I used this before already. Helix has a file tree now. I have no idea where when they added it, but we have that. Hub mode, binary body, hub use binary body, binary body. I'm gonna comment this out. I'm gonna create a file. Public struct binary body. So it's gonna have page size. Page size straight. Haven't added the most important feature yet though. Which one? Game of life buffer. Oh right. Well, game of life buffer implemented already. Just need to submit a pull request after plugin system is merged to have it vanilla. To have it built into the Helix. Page size straight. Zone body. What imports do we have? We have traits, alloc error, atomic use size, and other things. Import probably. File tree was built in or it's a plugin? It's built in. The file tree is built in because plugin system is not there yet. Minimum const levels size, number of smallest page levels. Wait, no, this is not not correct. So what they did, max order. I'm just gonna copy this. I don't really care about page size actually. Could be an experimental and closed. Huh? I should probably also leave a link. Binary body alloc less implementation of binary body. A very helpful article. Should I make it a link? Also. This was supposed to be that. Const max order. Size max order +1 list a pointer to list, well, a list, okay. Struct list, which just stores a pointer to list. Optional pointer. No, ptr. Like, I guess we could just do core tr non-null to list. Mutable pointer and stores inside a const pointer. Properties. Huh? It's always been non-null. Well, of course it's always non-null because it's an option. Although now I'm not sure if it will be non-null. Probably will keep it. Hopefully I'm gonna try. His max order. Well, let's just do 11. Although, why can generic arguments not be used? Huh? Where's the error? Where did it go? Anyway, page allocator trait for binary body. Oh, here we go. Generic parameters may not be used in const expression. Const parameters may only be used as a standalone argument here, i.e. max order. Feature generic const expressions. Do we need it? I feel like we do. More feature gates, let's go. Generic const expressions. Oh, experts. Right. Incomplete. Okay, sure, no. fine. We'll just do that. Now implement allocating trait for binary body. Its page size. So for every page size, which is page size trait, we'll implement this. It's super. Okay, great number, sure. Page size. Feel like we wanna move this to where? Okay, that's good. That's good enough. But first, we need to actually import binary body pub fn add or claim. It's called claim. So we claim mute self. We'll claim a region that's of size use size. So this region must be base. Do we do a pointer? Do we do a use size? Do we do a physical address? Do we do anything? I'm not quite sure about the use of physical addresses, honestly. Those structs. Word address, phys address. Maybe we should use pointers instead. Cause I wish we could use HJKL here. I don't know. Memory, address space has issues, right? Also, I can scroll here, which is annoying. So I was looking for address space, I guess. Well, yeah, use it for address, phys address. What could it be instead? So we map to pointer const u8. We map what? We map a u size. Size, page size, flags. I mean, I guess could get rid of another crate. We'll try. So since this must be virtual at least, core ptr non-null of u8. So if size, I should probably introduce a min size. Const min u size. Admin. So if size division reminder min, what do you mean bits? Yeah, anyway. 0 panic. Try to claim a memory region of size which is not divisible by min. Block size min. Should rename it to block size probably. Block size. So if base is not aligned, do I care? I kinda don't in this case. Maybe I should warn or something. So base with address, map address, provenance. What's provenance? I don't remember. Pointer map address. Yeah. So we'll split size up. So assuming it's visible, we'll need to find. Actually, let's just look at here. Look at the implementation. Pretty useful, you know. Oh, kernel layout. OpenSBI, huh? What's that? Anyway. So the allocator, let's see. Start and round set. And then level is next power of 2. Trailing zeros. Oh, okay, I see. I think I see. So we start with base and size, then while. Also, what's that? YouTube check as well. YouTube. It's broken. Might not be. You know, YouTube could always be like. YouTube chat could always exist, it just doesn't update sometimes. Okay, so expected, yeah, sure. So use loop colon loop. Okay, so if size, yeah, sure. Now we'll take size. Let's force it. Block bits. Ah, the light went off. Hold on. Well, that was an easy fix. For some reason, the switch I used to toggle the light just toggles back as if it had a spring inside. Let's just say that. For some reason. Anyway, so block size, block bits. Because we assume it's power of 2. I can do const mask with size. Useful or not? I'm gonna say useful. So 1 shift left times 1. Oh, they also do that, right? Oh, okay, fine. I'm gonna add parentheses just in case. Yeah, I think it would not work without parentheses now. So mask, if size bitwise and mask here. Size. Actually, I can do block size, which is this, and then mask is block size. Self. Alright, self block size. Now, so we have base, we have size. Now, while we can, well, we're gonna see, we're gonna claim first half. Actually, okay, let's check for address alignment. Is aligned to Align to align. There's metadata. We do ignore metadata. Oh wait, this is experimental. Pointer is aligned to. Excuse me. Well, I guess I could just cast to use size. Address non-zero use size. Get. Or could just cast as use size, probably. Oh, apparently this does not work. So if base address or size do not match, we'll panic, claim an misaligned memory region or memory region at base other gets at base of size where base equals to this. Ignore the formatting for now, please. Why does it not format properly? Because multiple. Okay, now why does it not format? Okay, now it should. Wait, no. No. Now it should have formatted. I guess I'll do it manually. Add of size. Mini block size is block size. Base is base address. Size is size, obviously. Block size is. Okay, now while. Well, so I should split it. If size power, if it's power of 2, then I can just add it to the corresponding order, or I'll let order equals size trailing zeros. So if so order is that minus log bits. So if it's yeah, sure, that should work. Well, actually no, block bits should be U32. Now, assert or order is, well, actually no, no asserting. If order is greater than self 0 len. Well, if it's below. I'm gonna say const max looks. I don't know. I'm just trying to optimize it so much. Let's check how they do it. So they go from order to max order. They do for HP, that's so fancy. Although I need a third range. So it's the size. Okay, let's copy that. Just add it. Python style. So we'll take that. Add count to size. Byte offset size yes underscore. Wait, it can easily be outside. Hold on. So while let's do size is above 0. So if so have a size. Smallest power of 2 greater than or equal to self, exactly what we need. Trailing zeros. So this is a level. So we'll do order, which is okay, so we take this, which is minimum of max order and this order. Okay, sure, that works. Well, I rename it to order. Then we do order dot push. Sure. Do we need a head or is a tail fine? Wait, we do head. You're right. Something like that. JSON syntax not valid rust item. Yay, an error. Our favorite. Enough. Most of a new self of none. Push self pointer to U8. So we do so here we'd push start. We'd push base. Non-null of U8. Yeah, of course. Non-null. Yeah, I'd like to import it. So we'll do ptr. It's only need ref. Can we cast it? SPTR. The cast as ref t as mute source there. Oh, here's cast. So we'll assign self. Wait. So at least. What? At least link. Okay, let's simplify it. Let's have a pointer to a list. Do they also do mutable pointer? Right. Yeah. They do use size though. Or PTR now. No mute. Okay. Now here. So self head self the 0 is gonna become PTR. No, it did like this a little better. So self head, we're gonna set it to sum now. Sum of PTR. So PTR is now pointer to a list. No. A mutable list. What? Type non-null cannot be dereferenced. SPTR. Equals, wait. So self is a pointer to a list. So we need deref self. Oops. Derive clone copy. So we assign to a pointer this pointer, and then we assign to the head this. Yeah, I should probably copy what they had. At least a little bit. Tr equals. So within a list. Oops. Recursive types. So we're gonna rename list to list node. List node pointer, because it's a pointer to a list node. Pointer to a list node. So yeah, we push to it. We'll assign head. So we'll the pointer we push is gonna store the current head, which is a pointer, and then we assign this head to which means okay, this should work. Now I'm gonna move this down here, or no, I don't know. I'm so unsure. Okay, so max order binary body. Now, when we claim create order, will push should claim be unsafe? Well, they have claim as unsafe probably. Also gonna add a pop later on. So claim I was gonna check alignment, and then so here we'll push it, and then we'll offset base. Wait, add. Oh wait, there's byte add. So useful. Okay, so we'll byte. So we'll change the base. I just like this better. Base size. byte add block bits although not like that. Wait, it's block size. Self. So we'll add this to base, subtract this from size. Should just be able to do this now. So this should work. This is basically a lockless. Now there's claims and pub. How unsafe is a lock? I mean, should be fine, right? Hidden pages. This takes self as mutable. It does. So we'll alloc this. We'll return optional pointer. Okay, so we'll return optional pointer to what? To this pointer node. Also, this is not aligned. So for page allocator, what we want is so for the page allocator, what we want is alignment. So I'm only gonna implement page allocator for it, for the binary body. Const block bits 1832. So for the allocate, we'll do. So we'll have lists of pages. Yeah, could just do page size once. I know, not sure. So join stuff. So larger pages, here they're not aligned, which is shame. And then you go through power stuff too. Memory exhausted. Yeah, no, not quite what I want, but pretty close. So here. So okay, so if base power of 2, wait no, so base size, so hard. What do we need? We have a base, we have size. We need to split it into blocks, which are aligned powers of 2. Yes. So if base is So we need the case where it is aligned to the block. If size is power of 2 and if base is aligned to that power of 2, and this power of 2 is small enough, and size 0, trailing zeros, binary representation of self. So if this is below or equal to max order, wait, this subtract, hold on. Back, low level RS, thank you for the follow. That is very fitting name. A very fitting theme. Okay, so if we subtract, what do we need? Block bits, right? From that. Okay, hold on. So if it's size of power of 2, let order equals this. If order is below or equal to block bits, that's pretty unoptimized, which is, I hate it. I hate it. Actually, can we do something like similar to this but different? If I take smallest power of 2 for size, well, smallest trailing zeros for size, and other one, or should we start with biggest? Yes, we should start with biggest. Cursive approach, go away. So while size is above 0, so we'll do this. So if one, four, it's gonna be trying to make sense here. So this is the order. So if it's one, might be too big though. Yeah, no, this is not quite right. Isolate highest one. Oh my god, that's exactly what I want. Assert and isolate highest one, just a random number, without ever specifying what n is. Perfect docs. Rust. Okay, so we need this. So isolate highest one, count trailing zeros, subtract block size. It's gonna give us biggest block, and then we'll do order min base address get, same thing. So this is a base order. Oh, unstable. Oh, so sad. So sad. Well, I guess we could just do leading zeros. So we could just do size dot yes, 32 bits. Can you expect any number other than 32 here? Okay, so we'll take order. Leading zeros -1 because yeah. This should be and subtract block bits. This should be order. So get address. So now order is minimum we can do, because if this thing is not aligned, doesn't work like that though. Why is it so hard? So have bits of address and bits of size. Bits of base and bits of size. So for the base we do want lowest. So if we take lowest for the base, trailing zeros. So here, this is the lowest order for the base, which means it's the biggest power of 2 sized block that base is aligned to, basically. Which makes sense. Next we'll min it with max order, which is I guess I could get rid of max order here. Just put in 11 bits, 11 levels. Then we add this to base, subtract this from size, and should add all the pages, right? Ideally I should write tests for it, but I might not, you know. We're gonna have self size, use size. Alloc order obviously needs self. Oh right, and we also need to wrap it in a lock. What's a lock? Oh, we need a mutex. We pretty much need a mutex. Get mute. So here, since we have exclusive access, or do we need exclusive access? Can we do exclusive access? We kind of do need exclusive access to it. So if we do so where do we use it? We use it in mod in x86, or actually in memory setup page. So before that we can't allocate, right? Well, we can't allocate unless we allocate, unless we want to. So here, well, technically we should be able to look at mutable. Yeah, but no, I should do that instead. Look. And then log. Actually, don't need to log here because we need max order, which I'm gonna bring back. Now alloc order is gonna return option because it might not be able to allocate one of what? What do we return here? A physical address. Well, I mean, in this case we'll do a non-null U8, so a virtual address. So if self 0 lock. Well, I should lock it. I should lock it like and yeah, just keep it locked. Let lists not mute. And then we'll do lists. And then we'll do lists len minus 1. And then I'll get rid of this one more time. So I'll change this to 11, not 111, just 11. Now, let lists equals self 0 lock. Now remember we don't we don't do recursion now. In those cases. So order equals size dot. So page size trait. We need something to get bits. Open bits. Use it to get for this page size. Of 2. Now x86 memory page size So 4K is 12. 4 megabytes is 24. Or actually, what is this? Come on. What? Ah. So this is the number of zeros. 22. Oh right, 10 more. So this is half of that, 21. 1 gigabyte. I actually don't know why it's don't remember. Just a 30. I wonder why it loses 1 bit each time in 64-bit mode. Wait, there's try from, there's no into. Oh wait, there is. Value power of 2. Power of 2. You're kidding me. Oh wait, power of 2 self. Or self like that, I guess. So this should be wrapper reduce 32 as number of bits. Now where's the degree? I don't get why it can't. Oh, here. There we go. So order size power of 2. So this is the order. So we'll do while, or I guess for, in order to slan. So we'll do order for each order from current order to the maximum order, excluding list then. So here we'll do lists order dot pop. So we'll need pop, which we'll do. So pop should actually be save. We'll return optional non-null. Option of non-null U8. YouTube check. Here. So here we'll do self 0. Match self 0. None, we'll return none. Some PTR, which is a pointer to list. We'll do PTR dot s PTR. So we'll do self was copyable, right? So assign the reference. That's safe enough. Picture. So what pointer points to will assign to self, which is a list node pointer, and the pointer itself will cast, and we will return it. Great. Now tr equals this so we'll take this, we'll take a pointer, actually, where is the merging part? Is a block into some blocks. So here it splits, here it doesn't merge. So we should probably merge when doing stuff. Okay. Get some tea. Implementing binary body for no reason. Didn't even get close to elves. Use with trash to detect use after free. Okay, so insert range does not care about merging, which makes sense, you know. Allog does, dialog does. Well, if you split, yeah, if you split, there's no way you can merge. Okay, so if mosquito, go away. So if we have the base, we have the page, we have the block, we'll need to split it in half and possibly split one of the others two in half. Let's just look at the simple. Well, okay, so they do order to I. So they use I here. Let's I pop. And then for J in what do they reverse. Makes sense, because so we go from I, from the current order to the smallest order, and we'll be splitting. So we'll take first half, probably. Or either example. Yeah, so base plus so we'll make it mutable. Then here oh, and this does not include I because yeah, we popped I already. So we'll push So we'll push into this one. We'll push the upper half. One shift left, or actually block self, block size, shift left I. So this is the current block size. So we'll do size, shift left by one, shift right by one, and then we'll push base add byte add size. So this is the second half. We push second half, and the first half is the remaining one. Okay, and then we can just return it. Some base. Yeah, doesn't really matter. And then here we'll return none because we could not allocate. Now, let's go here. I think we should get rid of physical virtual. Page size should be still here. Well, I'm not sure about non-nulls or pointers. If you should use non-null or a pointer. Because I know for a fact that this thing will not work for 0 page. Then from the scope. So this when allocated. Well, page allocator should probably return a pointer instead. So when we allocate a page, we'll just return a virtual address. Yeah, a regular pointer. It will take a pointer in the size. He will change this too much, change this too much. We know for sure that this is not null. But like, yeah. And for freeing, there's that. And then that's why either, well, yeah, to do for free for now. Kernel address space, I mean, do we really need kernel address space for anything? Let's see kernel tests. So it should at least run, right? No, it will not. Zone body, oh right. Normal address. Oh wow. Lazy0008, thank you for the follow. Why am I getting so many follows today? Just like out of nowhere. It's like 1, 2, 3. That's the fourth one. Anyway, thank you. So yeah, it's time to run tests, I guess. Although first of all, I'd like to get rid of some of those. Wait, so sync uses loc API. No, sync uses spin. Let me get rid of loc API then. Which crates do I need? So I will need elf. With no alloc feature. Because we don't have alloc anymore. Multiboot and x86. Talk, not needed anymore. Does not need any more memory address. Won't need it for now. Oh yeah, we'll need to pull up many things. Bit field struct, bit flags. We do need bit flags. And we do need spin. This error. This error, hold on, why do we have this error? Oh wait. Oh, maybe we do need this error. Let's see. Let's see like that. Should probably not compile. At least because we're using memory address still. Talk, yeah, useless. Lock API, yeah, maybe we do want lock API. Oh, and this error, yeah, this error is useful. Okay, so I think that's good enough for now. Now, I'd like to search for sync. Oh, this map to Mutex Garden stuff. Okay. Page allocator edit zone. So first of all, page allocator that we choose is gonna be binary body, which takes what? Block bits 12, because this is page size bits. Yeah, that's not gonna work. Oops. Yeah, good enough. Now, word address, phase address. Should I use my own structs instead? For that. So address space implementation. Yeah, let's comment it out for now. Hold on. Need to get rid of some things. So page allocator. We'll get rid of this. Address space, yeah, for now it's fine. And memory here, address space for now fine. TMP page will not be. It's not a thing anymore. Here. Now I could wrap it in structs, you know. I could, or I could not. Physical address, use size, virtual address, pointer. Or we could just do, oops, yes, underscore. Then virtual to physical is gonna be to size, same thing, but so this our kernel offset is a linker symbol. Linker symbol is this. Or should I do use size instead? Well, it should be virtual addresses mostly. Symbol name. As pointer const. Huh? You want that? Oh wow, that was interesting. Apparently, unsafe block is not considered an expression unless you wrap it in parentheses. Huh? Okay, so where am I? Wait, where am I? Let's close other tabs and oops, and run build. Well, obviously ignoring tests and also talk. Don't need that anymore because we're going a lot less. I'll probably regret it so much in the future. It's fine. We can always add talk back later. Oh wait, so if we go up further and further and further, oh my god, so many errors. Address space. Yes. Did I not comment this out for now? Will not test run Rust. Run. So what do we have here? Wait, can I scroll past that? Of course I can. No mapping flags, page table entry. Comment that out for now. Okay, so if we scroll up, here, archmod.rs address space 3. Oh my god, that's gonna mess up so many things. Can I just change this to static impl source page allocator, or actually page allocator trait, so that we don't have to worry about that. Kernel address space, comment that out. Commenting more and more things out, yay. Right, x86 memory mode. Yeah, line 53. Alright, we don't care about that. Comment this out. I'm gonna erase this. Actually, I should have kept the comment. Why can it not enforce this type? Okay, sure, fine. Also, yeah, we did forget about new pawn Stefan, new. All right, and why is const new separate? Rom mutex. Oh my god. Create mutex. No, I don't think this is the one thing. Consume rom mutex t. Oh, mutex. Create mutex. Sync mutex. Just sync mutex. Wait. Wait, it's not sync, it's spin mutex. Okay. That is a journey. Now page allocator cannot be sent between threads safely. Oh my god. What do you mean send is not implemented for a release pointer node? Do I care about send and sync? I don't see. Where is this list entry? So it's all operating within virtual addresses. Right. Welcome back, Nigel. Did I say that? Info unsafe send for list node ptr. I don't know what I'm doing, but oh, it's unsafe info. But yeah, living on the edge, sure. Sync. I don't care. Okay. Right now, I wanna go to linker symbol. Hold on, linker symbol. So we have, for example, kernel offset. I'm gonna do this. I'm gonna put a slash here. Kernel end is it's gonna be the default. Here. $2y. Okay, so this should work in theory. However, maybe not. Well, I know what to do. So we're gonna unpack it. Single TY. TY is gonna be optional. Well, it's gonna be necessary after all. But here it's gonna be optional. Single. Wait, so if there is no type, then we'll just do const here. Then here, name ident stuff. We'll just do ty is optional. Macro stuff, yay. So we'll split this up, right? Single name and then ty. Oops. Ty. So this should work. Nickname. What do you mean unexpected end of macro invocation? Converting into singles. Oh, wait, there's a semicolon for some reason. Sure. Fine, I'll do that. I'll also do that, and I'll also get rid of the repetition here. Oops. S underscore. Unnecessary cast, sure. But that works. Now that's a little bit cleaner here. It's gonna be a little bit cleaner here. Page allocator. So that should work. Address as use size, method not found. Page table entry, line 104. Wait, address is physical. Right. We don't care about this. A little bit left. Right. 66 memory mode. Line 76. Alright, this part. Okay, so memory area type start. First word. Actually, I mean, do I really care? In 1 to 2 hours. I don't know if I'm gonna be streaming in 1 to 2 hours, but see you, I guess, probably next stream. Thank you for joining anyway. You should get on the leaderboard, just as a reminder. Region start address as use size. Up to 4K line round rust round int up to yeah, init round integer. That's useless. Absolutely. You read the prompt, the search thingy. Something like that, I guess. Like there should be a function for that. It should be, as there is for pointers. Funnel shift, whatever this means. Strict add, strict sub. This will panic if it doesn't divide. Oh wow. Integer square root. No, it's gonna take forever. Also. Oh my god, I muted. Anyway. Next multiple of. Oh wait. Oh wait. This is what I need. Is it not? Okay, switch to Orco. Nah. Gotta finish this. You're gonna have one chance at one more chance. You might not. You might have wasted it, but you might have one more chance at Arch distro. Well, Arch remake. Next time, which might be tomorrow, might not. Anyway, so what do we need here? Next multiple of page size mean. What do you mean no mean? You're getting watch streak now. Well, yeah, Twitch watch streak has been broken, I think. Because that's just... it has been broken. I was not getting it, but sometimes I was. Like once in 100 streams or something. I do really mean 100 streams because it took many months for me to see the watch streak thingy. Like I was seeing it like very rarely, and then recently I think it started to come back more often or something. I don't know. I'm not sure. Texelware, alright, I'm safe. Yeah, it can't error. it can't error, right? It's so good it can't error. Aha. From pointer const u8. Wait, this was supposed to be like a mute pointer. Oh no. dangling. A new dangling pointer, yet it's well aligned. Anyway, from ref, from mute, from part. Is there from pointer? From immutable pointer, which is yes, s underscore. Name 0 page. So this multi. So there's next multiple. Is there a previous multiple? Yeah, sure, next multiple. So this should work in theory. Unused import in mode, unused import there. Mod res. Okay, so this one, right? Comment this out for now, get rid of this for now, I guess. Okay, we're booting. Or are we? Panicked at page fault. Let's go. Right, oh my god, I forgot we need, wait, no. It should have worked. SGX, why? What even is this? Okay, what even is this? Page fault, error, code x86, not x87. No, I'm not doing that. So who cares? Page fault here. Reserved SGX. Software guard extensions. Yeah, no. So only one bit was W. Right, but not present. What was the address? So we were we set up IDT. So the page was not present, apparently. Since we're using fist word, well, it might be more than 4 gigs. It might be 4 gigs of RAM. Don't or body. Or actually this. Allocating this to this range. Start and without worrying about alignment, of course. Oh, wait, this can easily go. This can easily break. Right. Well, doesn't really matter. Right. Okay. This does not clear it up. Okay, ATB000 to 7FE0000. AT to 7FE. So this is what? So this is 4K. So this gigabytes. Oh wait, this is megabytes. 128 megabytes almost. Huh. And then it hits page fault. Fortunately, at least I have exceptions for page fault setup. Okay, let's see. Allocating address. Okay, so we're allocating a whole bunch of addresses, and then on etc somehow it decides to not work. Also, I need to keep in mind that this is virtual. Hold on, or is it? Wait. Okay, so claim. So those are physical addresses. This is virtual address. What we're printing is a virtual address. Hold on, what? This is wrong. It was QEMU. Oh, wait. This is wrong because those definitely look like physical addresses. Well, the ones that we were getting at least for ATC0. So actually no. This is much bigger. So this is 260 megabytes. Oh, wait, yeah. And this was 258. Huh. How did it allocate the A1? Oh, 8, oh, A. 0 and then 4. Yeah. This is definitely outside of range. This is definitely outside of range. So minimum is so we need 2 gigabytes. Let's try hex 2 kilobytes, megabytes, gigabytes. This is this number. This is the most memory we can have for the 32-bit one. And it's also not gonna overflow, which is great. although start can easily overflow. Wait. Oh, what? Here. Here. So I also want to do this before other things. Page fault. It still wants to allocate this. What? It still tries to allocate this. Or move to lexpr, which is much more complex. Oh yeah, I don't know. Address. To 8 million. Let's try this. So we're still allocating to 7FE. Quadruple 0. Yeah, that's well below. So some logic is invalid. lexpr even has 30 support. It's more limited than using the core crate on its own. What? Yeah, so start this is wrong. Oh no. Wait. This is correct. This is correct. This is wrong. Wait, no, this is all correct. So on 260 for some reason it stops working. For some reason, at one point, it just fails. Fails to push. Huh. I wish I could. Well, actually, no, I can't print. I can in theory print memory maps. But I don't want to. If I made recursive add in lambda calculus, oh my god. You did using the Y combinator. I don't even know what the Y combinator is. I don't quite remember what lambda calculus is. But is that the thing where you use charge encoding? Or is it just... Well, lambda calculus is... pretty sure... You know... Does it have recursion? What? Hold on, how did you make recursive add without recursion? Well, I assume Y combinator is literally recursion. Wait, it says that thing that you sent me. No, that was recursive. Is it that? The way you do recursion. The function that takes itself as a parameter. Oh, yeah, sort of. So that's the Y combinator. Or That's how it does it. Whereas after GDTK setup, where is the oh my god, map higher half, stop at 0. Well, it should work. Okay, before setup paging, I'm gonna do oops, do create println value of the calculus doesn't have recursion, but it has copies, i.e. Why can we just emulate recursion? Okay, s pointer const to u8 u size and then I'm gonna dereference it unsafely. Wait, I remember that you couldn't dereference raw pointers in unsafe, instead you had to cast them to references. Was that the case? Or am I going insane slightly? Well, maybe not slightly, but you know. Okay, so if the page falls immediately, it's not even writable. Huh. But this is way below. What? I don't get it. This is above higher half, right? So if I take this number, and look at linker script, it's the same one. Yeah. Huh. Oh my god, what is this? fed. Oh my god, how am I supposed to read it? Arrow left not add. Natural add. So F. Okay, hold on. Length scheme. That's exactly what I was going to do. The sync copies. Wait. Not. Hold on. Okay, so it copied, but it copied a single parenthesis. Not very useful. Oh my god, how am I supposed to read this? This is why I think scheme is not readable. Okay, what is a $sign? Oh, $sign is defined, isn't it? Oh, this is... Wait, what the... Oh, this is two root terms. You can move them to two lines. Okay, so this is here. So this is the file. Two functions defined in this scope. File scope. Second line is the bootstrap add function. So define f. Why is y combinator called f? I assume that's the function name. Arrow. Parentheses. This is calling this function with this argument, which I assume those are identical. Yes. So it's a function. No, there's no scope. Oh wait. Oh, so this is the y combinator. You call it. So those are parameter names then. Okay. Yeah, when I saw x here, I figured out that those are parameters. So a function taking x and calling. So Y Combinator takes a function and invokes this on the takes a function, calls this function on x of x, and this of x will it should never get to f in the first place, should it? I'm like nearly about to copy all of this, paste it into AI and ask to rewrite in Python or something. Actually, I could do it myself. On link Python. What? Good enough idea. So it's lazy now. Okay, that changes everything. Okay, that changes everything, actually. That changes my understanding. Well, how did I just... Oh, ow, 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 what am I doing? Hold on. Those are extra pains. In non-strict languages, people use the Z combinator. What are non-strict languages? And I'm not even gonna ask what is non-lazy. Okay, I don't know what Z combinator is. I.e. strict. Okay, so this returns a calling of this, which basically returns a calling of f and then a call of this again. So it's infinite recursive call of f with an argument. Hold on. It's an infinite recursive call of f with an argument that, when evaluated, will call it again. Okay, hold on. So we infinitely recursively call this function with... Hold on, why does it take two arguments? Wait. It's not a religious topic, it's a name. I did not come up with this name. It's not on... Sorry, it's just... It's not me. It's just the name of the kernel. Parameters that will receive this function again. And be numbers. Oh wait, you have like... It's a higher power. Okay, wait. So Stack Overflow link first. Oh wow. Negative version. Well, I can assume how that works. I'm not gonna read it right now. So partial application, I assume. So this fed is the function that will recursive. It will be recursive. So when you call a fed, when you evaluate a fed, it's gonna evaluate this function again. Wait, how do you pass arguments to this? I'm not even gonna try to figure out how arguments are gonna pass there through this. Okay, so we return. What is that? What is that? A is not a function, B is not. Oh wait, or is it? Hold on, A is a function that. So A is a function that is I don't remember how you represent numbers there. It's a function that returns, that takes two arguments. First one being a function that takes a number 1 less than a, and second one being the function that takes 0 or 1. 1 I assume, because not natural. No. Or maybe yeah, actually. Maybe it first takes 0 function. So a takes b as the first argument, which is a function that is evaluated when a is 0. Am I right here? Because otherwise it would not make sense adding stuff together. Or maybe no. Or is it 1? Is match a with 0 to x successor. Yeah. I was just talking about 0 or 1 because since it's net, I would expect 1 here. And then I was afraid of the fact that you wrap b somehow in this like thing. A predecessor is gonna return all of this. So we call this thing 1. So we add to b to a predecessor. So a plus b, a minus 1 plus b, and then you add 1 to it. So this function was supposed to add 1. This is so difficult. Wait, why does it take 3 arguments? Oh wait, that's because that's how the thing works. Yeah, okay, I see. That's successor. I know that this is successor because I know we need to get the successor of a number. I just didn't. Okay, now implement macros. Because reading this without macros is difficult. But yeah, I see. Because a plus b is 1 plus a minus 1 plus b. That's so... imagine how much computation you waste on a recursion instead of just using binary adders of your computer. Like, that's what bugs me. Cool coincidence because macros is exactly what you're working on. Is it a coincidence though? Okay, so where is Bootstrap? Oh wow. Admirin, thank you for the raid. Welcome in. So yeah, we're... I don't know if I can even show it much. So we were going on a little side tangent because Nigel was doing lambda calculus stuff. But yeah, right now we're basically making an operating system, which, if it compiles and boots, then we get a page fault, and I don't know why this page fault happens. But yeah, it was supposed to allocate pages, and we were supposed to be working on ELF files, but nah, that didn't happen. So yeah, now trying to figure out why it page faults. And it page faults with no flags, which is even worse. So yeah. Not present, not writable. All zeros. I assume more art. I assume I'm doing more art. It's fine. What were you drawing though? That's the question. I joined for like a couple of seconds when you started because I was already live at this point. One day I'll make a music stream. One day. Okay, so map higher half, which is what matters. Krita or A sprite. Rather. One of the cutest plushes. Wait, what? Why did it? I don't have GIMP. I don't have a sprite, so it's gonna disappear at some point. GIMP better than Krita. Hey. Okay, I'm not sure. I'm not using Krita and GIMP much, even though I'm pretty sure I have. Yeah, I have Krita only. GIMP 2 is better than Krita, with an asterisk. Oh, what? Yeah, A sprite is better than all of them. Honestly, I'm so used to A sprite that I use it for everything. Even to just take a screenshot, paint something on top of it. Like with a red paint to highlight a part. Like or draw an arrow. I just use A sprite because shortcuts in A sprite, that's just what I'm used to. It lags with big screenshots, it lags with big pictures. I was using A sprite to clip Discord messages together for a video I was doing. So I love A sprite. Pretty much my favorite image editor. I should probably get used to Krita because it's useful. Which was? Well, it was jumping around because it broke. That's what I remember. Okay, text and raw data, and then we have this until 0. Okay, let's try debugging it. Which means emulator boys run breakpoint on where. We'll continue here. Oh wait, I did not put a breakpoint. Hymen glow. Wait, key setup is. Oh wait, or is it key main? No, it's key setup. How do I breakpoint? How do I put a breakpoint? You continue, sure. It's gonna page fault. At some point. At some point it should. Right? Yeah, here we go. Not very useful though. So let's check. Oh, I don't remember. Do that. Boys. Nigel, you don't have scheme. How dare you? Well, you can't have two plushes at the same time. You may ask somebody in chat. Hold on, what? Alright, you can. Wait, you can catch a plushie without any plushes, right? That's fine. You cannot damage. But print. is it memory map? Because I don't remember all the comments. Wait, in OSDev wiki. OSDev wiki should have some. Let's see. Print. I don't remember where I was reading the docs. Closure? I'm pretty sure we had closure. Wait, Hextrace docs. That might be better. I'm pretty sure we had closure. Out of 172 or something plushes. Let's check. Okay, maybe not. How does it look? What does it look like? I feel like we had that. Well, maybe no. maybe we didn't. Probably something similar. Okay, push debugger. Print page tables. Oh, info. Info. Okay, let's see. Tab, info page tables. So from 0 to 3FF. So for 40 hex. Oh wow. So it's 64 page tables, 64 4KB blocks, which is 200 kilobytes identity mapped, and then we have this to 80B. Excuse me, it mapped everything up until C, which is what we were trying to access. Okay. Oh wait, it's also. Oh what? Oh wait, the stop. Up to BFF. Huh. It's weird. Okay, let's loop here. Okay, so for some reason it did not map the whole way through. Not this again. I don't want to deal with assembly again. Last time it broke everything. So I'm covering chat, sorry. Closure sent already. Well, you're about as quick as always. Although I'd like to info tab first. Paging off. What? Oh wait, yeah, we need to wait a little bit for it to load. Now here, info tab. Also YouTube check, just in case. So yeah, up to BFFFF. Wait, I might know why. Something overflowed. Huh, what? Wait, no, all those are 32-bit registers. How could they overflow? Okay, since I just sent closure, let me open it here, just in case. Wait, it's 3:25 p.m. I've been streaming for 4 hours. Doesn't really feel like that. Okay, so closure sent. Add start. Oh, okay, we can quickly do that. That's how you spell it. Actually, let's see. Okay, groups. CLJ aliases. Categories Lisp. So first of all, it's not categories, it's groups. Second of all, Lisp. You want me to add Lisp category? Because I don't think I have it, and that would mean adding all the languages, which, yeah, I don't know which ones could be considered Lisp. No, I don't. Okay, let's now restart real quick. Please do not write anything in chat until the overlay loads up. Heat. Okay, here we go. Oh wait, hold on. No, 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 no. Oh wait, Discord is wrong. Hold on. I forgot that I need to re-import it. Can I look at though? Is there a re-import like CLI thing? Oh, here, import. Hold on a couple of seconds. It takes forever. Oh, here we go. Close that then. Well, it imported. Why does it not? Oh, here we go. Okay, now hold on. Oh, here, restart the overlay, and it should now be there. You may test. Here we go. Anyway, you actually don't like closure. Why did you add that? Imagine a Lisp that doesn't have currying. Can't imagine that. But does it mean it has literal multiple arguments and doesn't have partial application? That would be curious. Oh wow. Yes, yes. Well, I mean, I like languages that do not have currying because I don't like Lisps. But yeah, I know. I guess as a Lisp it's something awful. Anyway. But that includes OCaml and Haskell doesn't have partial application. And OCaml doesn't have partial application. I mean, I don't know much about OCaml, but the fact that Haskell doesn't have... Okay, partial applications they do have. But they don't have currying. No, Haskell has currying. Haskell just has syntactic sugar to make it easier. Oh, all nice Lisps, OCaml and Haskell. Okay, that makes more sense. Now, I want to figure out why this is messed up. Why this doesn't map all the things. Let's just... Oh, wait. Let's just run it. Oh, wait, and enable paging. It's fine. Can continue. Wait a little bit more. I'm pretty sure there was like interrupt to trigger a breakpoint. We'll just wait for CD to go off. I guess it should turn off at some point. Yeah, here we go. Now, yeah, that's exactly what we need. Now, so this should be off. Wait, skip. I don't remember. Into I think it's interrupt to that I need in order to trigger breakpoint. I don't quite remember, but I think it's number 2. Loading up. Oh wait, here we go. XOR out. What? Segmentation fault. Okay, whatever. Maybe it wasn't a breakpoint interrupt. Oh wait, it's not. Exchange AX I think it was. Which software breakpoint? It's BXBX or int3. Exchange BXBX. can I not? So this should at least break point. I should have just probably put a breakpoint after the thing. That's perfect. Now info tab. Oh yeah, it just ends at BFFFF. So weird. One byte, 2 bytes. CF. 3 bytes. Can I print the value of EAX at the breakpoint? Scheme doesn't have partial application either. Oh. Page. Is it for CPU? Yeah, let's see. RAX 0. Okay, so it did complete the cycle. Oh wait, EX is the one, ESI. RSI. This does not look like what it... JB. Jump below. Yes, we have ESI compare ESI X. x86, i686, compare unsigned 32-bit jump if below, something like that. Can probably do it with macros. Okay, AI, whatever. Can we disassemble a map? No, not a chance. Your language, the one I pasted into Helix has partial application. Signed. So this is unsigned. Why did it break then? EAX, ESI. Can you emulate compare instruction, please? Okay, maybe can I get flags? ID, VIP, VIF, AC. Okay, doesn't tell anything. See you, Nigel. Bye. Okay. This does not make sense. The CPU does not support AVX state, AMX state. I don't care. Okay, what's wrong? Tag word 5555. RDI. 8, 9 up to 15 RIP. Well, they all look correct. This doesn't quite. Actually, maybe this. Yeah, this is fine. RSP looks pretty correct. Why does it break? Why did you break? Why did you not execute when I compared the SI and the AX? Okay, let's go. Okay, so this should trigger here once, here the second time, and we need the third one. Time, and we need this CPU. Let's see. So this is right after jump below, so pretty much right after compare. RAX, well, EAX 0, ESI, RSI 0, 0C 0, 0, 0, 0, 0. E flags status word. Now how do I need to read E flags? CMP instruction x86. I need docs. Exception, flags affected. CF, okay, let's see, if flags, condition codes, well, let's see if flags meaning x86. CF carry flag. So CMP is basically subtract EX minus ESI. Oh wait, ESI minus AX. So once ESI becomes smaller, wait, so ESI is increasing when it becomes larger. So while it's smaller, so if it's so meanwhile ESI is smaller, which means it's probably EX subtract ESI. Or is it ESI subtract EX? Well, if carry flag is 6, hold on. 6 is 2 flags set. So 4 and 2. Always 1 and parity. PF. Okay, and normally, which means normally carry is on and is below. Why? Why? I don't get it. Why are you breaking out? How did it break out? So it's 2 bytes and then C0. And get it. (12 megabytes). So on 12th megabyte, it just randomly decides to break out. Why? Okay, maybe I do not know something about it. Went with the second source operand and then sets the status flags registered to by subtracting some instruction. When the minute value is used, it is signed extended to the length. Okay. The condition codes used by jump conditions, remove conditions, set conditional instructions are based on results from C instructions. Appendix shows relationship in 64-bit mode. Default size is 32 bits. Use REXR prefix to permit access to additional registers. Use of the W prefix promotes operation to 64-bit. Yeah, I don't care about that, we're in 32 bits. Summary chart, the beginning of the section for encoding data and limits. CF, OF, SF, ZF, AF, and PF. Okay, let's see. Appendix B, flag condition codes. Where are condition codes? Explain please. Monic, B. Below or neither above nor equal. Okay, so it's CF equals to 1. Why is CF 0? Okay, you're subtracting this from 0 and getting no carry. What? Let's put the result in EAX, which we don't care about. Wait, no, let's put the result in SI. Same thing, although this time what? It reduced. Okay, sure. That means it does put result in SI. What does it mean though? So EAX. So ESI equals ESI minus EAX. Right? But EAX is 0. Well, it's not in most cases. But like, what's the point? I don't get it. I don't get why it doesn't work. Why it works like this. Okay, let's check first one. Go ahead. Come on. No. Info CPU. So this was EX4 400,000 hex. RSI 400,000 hex. Yes, it got there. It said 0 flag because it got equal. This time. I also wanted to try something. Oh, stepping right. So 800,000 hex. 800,000 hex. GF is set. Okay, step. Move values. Call. Move or move add. Add. Compare. Now. Oh wow, CF is not set. Wait, oh my god, 0 is below, 0 is smaller. Okay, this fixes. Okay, so the whole memory mapping thing we had just doesn't work because I'm dumb. Okay, so let's set it to not equal and hope it's gonna be fine. Well, I mean, I'm only using this subroutine in 3 places, so it should be fine. Let's go, it allocates memory. It sets up everything. Let's go. 81 FE. Okay. Wait. Okay, let's run it in QEMU now. That was much faster. Okay, now let's see. This is 87 FC. Let's do. Yeah, let's get rid of that. Let's close that. Let's go into get rid of print, and let's read number of allocations. It's gonna be difficult. Well, anyway, we'll get to it later. Yay. So it should work. We need tests for memory allocation stuff. Let's go to tests. Test syscalls, test page. Test okay, let's comment out test syscalls. Page allocator kernel data space. Okay, so yeah, kernel data space. Yeah. Oh, this is x86 tests. Well, it shouldn't really be x86 tests. Should be just regular tests. Okay, so this is obviously not gonna compile because kernel address space does not exist. Yay. That they implemented. But I don't know. Maybe we'll do this next time because it's 5 hours. Well, 4.5 hours. I mean, I guess I could go for a little longer. Because I'm feeling much better than when I started. Streams have positive impact on my health apparently. Now. Oh, total memory. Yeah. Okay, fine. Let's go into page allocator and implement total memory. Also, what's there? Function new is never used. Well, sure, I guess. Oh, base does not need to be mutable. Right, because we're never mutating it. Now fn allocated self. So let's go to, there's literally a leaf just fell from one of the plants. So let's go to that very useful article. I should probably read all of this. Scheduling, synchronization and stuff. Okay, so let's copy this itermute. Pretty simple, should be. Alright, because you need another struct for this. Wait, can I do iterator? Therefore list wait, I can, hold on, non-null u8. I can basically do this. Also, this is literally map. ETR. Yeah, because we don't need this. Oh wait, and then. Right, and then. Wait, it's just map because we don't need this here. Now, as this. Oh, this is literally popping. So we're taking current pointer. If it exists, we will return it, and then change self. But it's not gonna. So important point is okay, let's do lists. For list in lists. For for order in to also, yeah, I might have messed it up a little bit somewhere. Somewhere here. Wait, no, it's correct. Although do bits. Should do that. Because we convert size to blocks. Okay, so from 0 to, well, actually I could just do list iter enumerate order list. So we can do block size left shift order. Also we can do sum. Okay, so this is the size multiplied by list clone. First of all, iterate count here. Temp annotations needed for this. I mean, I don't want explicit type, do I? For some reason it's angry at me. Some self. Oh wait, because we need to map first. Here. And the number of bytes allocated for this available. Allocation. Actually, minimal blocks. Number of blocks, let's just say. So if we multiply this by page size, so let's comment this out. Comment this out. Let's see. Oh wait. Test. We need to we need to do tests. We need to run tests. Map 3. Did I not save it? Keep memory available, huh? Line 42. What do you mean? It's commented out. Is it not? Huh. That's 46. Oh wait. I did move the file, but I didn't move it in Helix. As always. Okay, now tears out on available. Available. Alright, because we don't have that. Which shirt's that? Private module. Why? and types are erased. Now I know. Not included feature. Each allocator. Okay, so I know what I could do. Oh, it should be able to reach it in theory. Okay, testing finished. Rapid and display size, or whatever I call it. Create memory. Oh, right. So annoying. Yeah, display size. YouTube check just in case. Because YouTube doesn't update. Did you know? Expected found size. Alright. $119 megabytes. Because we only allocated one thingy, which sounds correct. You immute set RAM size. Minus M. Build Sage. Immute. So for test. Is it run? Wait. Is it run that runs tests? Yes, it is run that runs tests. Okay, so if we can do there's 512 for 512 megabytes, which is about 509, well 503 I guess. 1024 for 1 gigabyte, and at 2 gigabytes it should in theory, it's gonna take a little time, 1 gig at, okay, let's do 4, wait, 4 gigs of RAM. It should only allocate 2. Ooh, errors. Pointer add requires that the address calculation does not overflow. Yay, we've overflowed. Oh no. Okay, where is it? Oh wait, there's no backtrace, right? Okay, so null add. Well, it should have saved itself. It didn't though. Memory up to 8 million. Well, it did limit at least. Wait, no, it didn't. Yeah, no, 8 million is limited. Well, this where we actually do the allocation. Yeah, no, it did limit. And then we do conversions and rounds. And for some reason, well, yeah, sure, non-null could overflow if we got the end address, but we shouldn't have. Oh, it might have been there. It's probably there. Back for a bit. Oops, it's fine. Okay, so we figured out the error. It was me. Yeah. I could try explaining it, but it's so deep. Well, in short, some assembly. It's it's mapping memory, doesn't really matter. What matters is that I set so it maps memory from in a range from start to end. I set end to 0 so that it would map the whole thing. But instead, my checks were if the current pointer is like below the end, then we continue mapping. If it's not, then we stop. It looks unreadable. Well, that was supposed to be unreadable. I mean, no, but it's just assembly. It doesn't have to be readable. Point is, I was relying on the fact that once we finish going through the whole memory range, we wrap back to 0. However, my code was also like, okay, so we're past 0 already. Let's stop and not map anything else. Yeah, that was basically the reason. And I did not notice that this didn't work for a while. Until today, basically. Now it seems to work, although if I allocate the whole 4 gigabytes it breaks. But that's kind of expected. I think it's there. Okay, so if size is 0, break. Now let's see if it breaks, or if it allocates the whole thing. It allocated 1.9 gigabytes. Let's go. Because limit is 2, and other 2 gigabytes are ignored. But that doesn't really matter, because it's not gonna stay on 32 bits forever. We're gonna expand more. So by default, QEMU gives it just 200, well, 119, 128 complete. Okay, so this works. Now we'll just need to do some tests to rewrite back memory mapping stuff. And wait, let's commit. Rewrite allocation logic completely. So we're yet to rewrite again all the memory mapping stuff, memory unmapping, memory deallocation. Yeah, that's gonna be fun. Actually, haven't tested memory allocation yet either. On page allocator should at least test allocation. It's pretty simple. It's just Rust. If you use it for a while, you'll get used to it. It looks weird and scary. In fact, to me, all the Lisp languages look weird and scary. But if I learn them, which I wouldn't, then I would be able to read them easily. I know that. That's just how programming works. Again, if you listen to Latin, you're not gonna understand a single word. Probably. Unless you're like Italian, French, which languages are from that family. But if you learn it, you're gonna start understanding it. And in fact, you're gonna see a lot of references in Latin in many things. Not like references, but names, which literally translate to the character of the person who was named. Yeah. That's just how it works. Now, if we alloc each size, okay, I'm just gonna where is it? Default. I'm just gonna enable kernel test because it's so painful to work on those tests. Okay, hold on. Here, page size, which is create arch create arch memory page size. Wait, is it not there? Oh wait, we don't have traits imported. No, we do. 4 megabytes, for example. Oh, this again. This is as memory trait. Well, can I actually go to x86 straight? No, not really. Can I do this? Named example. Well, it's memory as memory. No, this is alien language to me. I don't understand why. How to do this? Is memory trait. Will this work? Probably won't. But what if it will? It would be really nice. Oh wait, it does. Wait, what? Oh, I think it does. Okay, and then we'll print memory after we allocate. After alloc. And it should be 4 megabytes less. And I think that's where I'm gonna end about. Yeah, 4 megabytes allocated. I assume it will it is actually allocated and it will actually work. Well, I mean, it can't, because that's the allocator. Only thing bad that could happen is it if it returns it again, if I try to allocate it again, which no, will not happen. So I'll remove that, and I think we're gonna end there. Because, yeah. This seems to work. Might continue on tomorrow, but probably it's gonna be different stream topic. Because, yeah. Oh, and developed from scratch life. Who's doing operating system development. Perfect. Well, kind of was that, but still perfect. So I think let's rate them and see. Here. Thank you for joining. Thanks Admarine for the raid, and I'll see you next time. Bye. That reminds me that I need to open this first. Okay. Bye. Goodbye, YouTube.